On November 14th, 2023, Voyager 1, the iconic spacecraft that had ventured beyond the solar system, suddenly fell silent. Instead of its usual stream of valuable data, it began transmitting only a meaningless cascade of binary code. It seemed as though the probe, which had journeyed farther than any human-made object in history, was lost forever. The cause of this heartbreaking silence was traced to a memory failure in its onboard flight data system, FDS, threatening permanent loss of communication with Earth. But the team of scientists, refusing to surrender to despair, made a bold and unprecedented decision. They chose to reallocate the spacecraft's code to other areas of its memory, a risky maneuver that could either save the mission or doom it entirely. This daring process began on April 18th, 2024. Each attempt was a leap into the unknown, as every signal took 22.5 hours to reach Voyager 1, and another 22.5 hours for a response to return. The tension was palpable, the stakes unimaginably high. Then, just 2 days later, after months of relentless work and a nail-biting anticipation, something extraordinary happened. Voyager 1 re-established contact. The relief and triumph were overwhelming, but the questions lingered. What had Voyager 1 discovered at the edge of the solar system? Why was it so different from what scientists had imagined? And what secrets were hidden in the mysterious signal it sent after months of eerie silence? The story of Voyager 1 and its twin, Voyager 2, began in the late 1970s during a rare celestial event, a planetary alignment that occurs only once every 175 years. This alignment placed the gas giants on one side of the solar system, creating a unique opportunity to study them in a single mission. NASA seized this chance, launching Voyager 1 and Voyager 2 on a grand journey of exploration. Voyager 1, traveling at a staggering 38,000 miles per hour, outpaced its twin and captured an historic photo of Earth and the Moon just 13 days after launch, from a distance of 7.2 million miles. This image became a symbol of humanity's reach into the cosmos. By 1979, both probes reached Jupiter, unveiling its previously unknown rings, discovering 3 new moons, and capturing breathtaking images of its largest satellites. They confirmed that Ganymede, not Titan, was the largest moon in the solar system, and revealed Europa's icy surface, riddled with cracks, sparking the hypothesis of a subsurface ocean. The probes also provided the first close-up view of Jupiter's Great Red Spot, a centuries-old storm larger than Earth itself. Using Jupiter's gravity for a speed boost, the Voyagers reached Saturn in 1980 and 1981. This marked a turning point in the mission, which was initially planned to last only 4 years. A key decision was made to direct Voyager 1 toward Titan, Saturn's enigmatic moon with a dense atmosphere, while Voyager 2 continued its journey to Uranus and Neptune. The probes delivered stunning images of Saturn's intricate rings and discovered 4 new moons, including Mimas, whose massive Herschel crater gave it an uncanny resemblance to the Death Star from Star Wars. Titan, however, remained shrouded in mystery, its atmosphere opaque to visible light. Yet analysis revealed that Titan's temperature was near the triple point, where methane behaves like water on Earth, hinting at a world of strange and alien possibilities. After Saturn, the paths of the 2 probes diverged forever. Voyager 1, accelerated by Saturn's gravity, became the fastest spacecraft in history, while Voyager 2 continued its planetary tour reaching Uranus in January 1986. Scientists were stunned to find that Uranus was vastly different from Jupiter and Saturn. Beneath its atmosphere of hydrogen and helium lay an ocean of water, ammonia, methane, and hydrogen sulfide, with a core of rock and ice. Uranus, the coldest planet in the solar system, defied expectations and earned the title of ice giant. Voyager 2 then journeyed to Neptune, arriving in August 1989 and capturing the first detailed images of the vivid blue planet, completing its grand tour of the solar system. Meanwhile, Voyager 1, its instruments largely deactivated after its Saturn mission, had one last historic moment. On February 14, 1990, from a distance of 3.72 billion miles, it captured Earth as a tiny pale blue dot, just 0.12 pixels in size. This iconic image, known as the pale blue dot, became a poignant reminder of our place in the universe. After this, both probes entered a long period of quiet, their cameras permanently shut down. But their journey was far from over. On August 25, 2012, Voyager 1's instruments recorded a sharp drop in solar particles and a rise in galactic cosmic rays, signaling that it had entered interstellar space, the region beyond the Sun's influence. Voyager 2 followed suit in November 2018. The data they sent back revolutionized our understanding of the solar system's boundary, the heliosphere. Contrary to expectations, the solar wind doesn't gradually fade, but instead forms a sharp boundary, the heliopause, where it meets the interstellar medium. The heliosphere, shaped like a sphere on one side and a long tail on the other, is constantly shifting, distorted by massive waves that defy explanation. The temperature and density of the solar wind near the heliopause were far lower than predicted, leaving scientists baffled. The Voyagers also revealed that interstellar space is filled with denser, colder plasma, while the plasma near the solar system's boundary is hotter and less dense. Shock waves from the Sun can pass into interstellar space, creating disturbances similar to those caused by supernovae. The interstellar magnetic field was found to be 2 to 3 times stronger than previously thought, exerting immense pressure on the heliosphere. These discoveries have profound implications for our understanding of not just our solar system, but all stellar systems in the universe. Despite their incredible resilience, the Voyager's journeys are nearing their end. In 2022, Voyager 1 transmitted a strange signal from 14.6 billion miles away, later determined to be a malfunction caused by cosmic radiation. Then, on November 14, 2023, it fell silent for 5 months due to corrupted code. The team's daring decision to reallocate the code saved the mission, but the clock is ticking. NASA hopes the probe's instruments will function until 2025, after which a phased shutdown will begin. These malfunctions are a stark reminder that the Voyagers, our cosmic pioneers, are nearing the end of their extraordinary odyssey. Their legacy, however, will endure forever, a testament to humanity's insatiable curiosity and unyielding spirit of exploration. The Voyager spacecraft, humanity's farthest-reaching emissaries, are nearing the end of their ability to communicate with Earth. Around the 50th anniversary of their mission, they will lose the energy needed to send signals back home, marking the final chapter of this groundbreaking project. Yet even after falling silent, these cosmic travelers will continue their eternal journey through the vastness of space. They may witness extraordinary phenomena, collisions of stars, the birth of new worlds, or even encounters with alien civilizations, but they will no longer be able to share these discoveries with us. Voyager 1, moving at a staggering speed of about 3.5 astronomical units per year, 1 astronomical unit being the average distance between the Sun and Earth, approximately 93 million miles or 150 million kilometers, is currently heading toward the constellation of Ophiuchus. In the year 4272-38,200 years from now, it will come within 1.7 light-years of a faint star in the constellation Ursa Minor called a C plus 79-3888. Its twin, Voyager 2, is traveling slightly slower at 3.1 astronomical units per year. Around 40,000 years from now, it will approach within 1.7 light-years of Ross 248, a small star in the constellation Andromeda. As of now, Voyager 1 is approximately 15.5 billion miles from Earth, while Voyager 2 is 12.4 billion miles away. Although both probes have crossed the heliopause, the boundary where the Sun's solar wind gives way to the interstellar medium, it's not entirely accurate to say they've fully exited the solar system. Scientists believe the solar system extends to the Oort cloud, a hypothetical spherical shell of icy objects surrounding the Sun at a distance of 50,000 to 100,000 astronomical units. This region, the source of long-period comets, marks the true edge of the Sun's gravitational influence. Voyager 1 will take roughly 300 years to reach the inner edge of the Oort cloud, and another 30,000 years to traverse it, finally marking its departure from the solar system. If, on their distant journeys, the Voyagers encounter extraterrestrial life, they carry with them a message from humanity. Each spacecraft is equipped with a golden record, a gold-plated copper disc containing sounds and images of Earth. The records include greetings in 55 languages, messages from world leaders, the sounds of nature, human voices, whale songs, and even brainwave recordings. These time capsules, designed to last billions of years, are a testament to humanity's curiosity and creativity. Yet if the Voyagers are never discovered, they will continue drifting silently through the cold, dark interstellar void, eternal symbols of our quest to explore the unknown and our hope that somewhere, someone might one day hear our story. The Voyager mission began in 1977, when Voyager 1 and Voyager 2 launched from Cape Canaveral less than a month apart. Interestingly, Voyager 2 launched first, but followed a slower trajectory, reaching the edge of the solar system 6 years after its twin. As the probes ventured farther from the Sun, they made a startling discovery. The density of space increases as you move away from the Sun. Interstellar space, often thought of as a perfect vacuum, is not entirely empty. The solar wind, a stream of charged particles emitted by the Sun, has an average density of 3 to 10 particles per cubic centimeter near the Sun, but this density drops significantly as you move outward. At the heliopause, the boundary where the solar wind slows to zero, the density of particles is just 0.002 per cubic centimeter. Beyond this boundary, in interstellar space, the density was expected to rise to 0.037 particles per cubic centimeter. Voyager 2 confirmed this, measuring a density of 0.039 particles per cubic centimeter at a distance of 119.7 astronomical units, 17.9 billion kilometers from the Sun. But then, something strange happened. At 124.2 astronomical units, 18.5 billion kilometers, the density jumped to 0.12 particles per cubic centimeter. Why? The answer lies in the collision of solar and interstellar plasma, creating a cosmic traffic jam of particles at the heliopause. This discovery is just one piece of a much larger puzzle. The solar system is nestled within not one, but two cosmic bubbles. The first is the heliosphere, a protective bubble created by the solar wind that shields the planets from high-energy cosmic radiation. The second is the local bubble, a vast region of space surrounding the Sun, stretching 1,000 light-years across. This bubble, formed by a series of supernova explosions over the past 14 million years, is still expanding at a rate of 4 miles per second. Its surface is dotted with star-forming regions, where new stars are born from the dense molecular clouds pushed outward by the supernova. The Sun, which was not originally at the center of this bubble, entered it about 5 million years ago as it orbited the Milky Way's center. This fortuitous placement has profound implications for life on Earth. The local bubble's low density of interstellar gas and dust has allowed us to observe the universe with unprecedented clarity, revealing the structure of galaxies, the birth of stars, and the remnants of ancient supernova. But the local bubble is not unique. The Milky Way is filled with such bubbles, each created by the explosive deaths of massive stars. These bubbles act as cosmic nurseries, fostering the formation of new stars and planets. As the Sun continues its 200 million-year orbit around the galactic center, it has likely passed through many such bubbles, each leaving its mark on our solar system. In fact, scientists have found a correlation between the Sun's passage through the dense spiral arms of the Milky Way and mass extinction events on Earth. The higher density of interstellar gas in these regions may have exposed Earth to increased cosmic radiation, disrupting the climate and triggering extinctions. Today, however, the Sun resides in a relatively quiet region of the galaxy, a safe harbor that has allowed life to flourish. The Voyager's journey has also revealed the intricate interplay between the Sun and the interstellar medium. The heliosphere, shaped like a sphere on one side and a long tail on the other, is constantly buffeted by massive waves of interstellar plasma. These waves, some reaching 10 astronomical units in height, distort the heliosphere's boundary, creating a dynamic and ever-changing frontier. The temperature and density of the solar wind near the heliopause defy existing scientific models, with measured values 10 times lower than predicted. Where this energy goes remains a mystery, one that challenges our understanding of the universe. In 2022, Voyager 1 transmitted a strange signal from 14.6 billion miles away, a chaotic stream of data that puzzled scientists. The cause was eventually traced to a malfunction in its altitude control system, likely caused by cosmic radiation. Engineers managed to fix the issue, but it was a stark reminder of the probe's fragility. Then, in November 2023, Voyager 1 fell silent for 5 months due to corrupted code in its memory. In a daring move, scientists reallocated the code to other sections of the probe's memory, successfully restoring communication in April 2024. These malfunctions are a poignant reminder that the Voyager's time is running out. NASA hopes their instruments will function until 2025, after which a phase shutdown will begin. But even as they fall silent, the Voyagers will continue their journey, carrying with them the hopes and dreams of a species that dared to reach for the stars. In 1977, as Voyager 1 and Voyager 2 launched from Cape Canaveral, they carried with them not just scientific instruments, but a message to the cosmos. Today, as they drift through the interstellar void, they remain a testament to humanity's boundless curiosity and unyielding spirit of exploration. They remind us that even in the vast, cold expanse of space, we are not alone. We are part of a universe that is alive with possibility, waiting to be explored. And as we listen to the faint hum of interstellar plasma, recorded by Voyager 1 from 14 billion miles away, we are reminded that the universe is not silent. It is alive with the whispers of stars, the echoes of supernovae, and the promise of discoveries yet to come. The Voyager spacecraft, humanity's farthest-reaching emissaries, are nearing the end of their ability to communicate with Earth. Even using radio signals, which travel at the speed of light, it takes more than 20 hours for a message to cover the immense distance between us and Voyager 1. The sad truth is that soon we may no longer receive any signals from this iconic probe. Scientists estimate that Voyager 1 is running out of power, and its crucial instruments may only function for 3 or 4 more years. Yet Voyager has already exceeded all expectations, and it could still surprise us with groundbreaking discoveries in the years to come. While the latest findings from Voyager are significant, NASA has previously uncovered other mysterious sounds that have left scientists baffled. In 2007, researchers stumbled upon something bizarre while reviewing old data: fast radio bursts, FRBS. These bursts are incredibly brief, lasting only about a millisecond, yet they pack a powerful punch. Since their discovery, scientists have identified numerous FRBs, each raising more questions than answers. Could these bursts be attempts by an intelligent alien civilization to communicate with us? Or perhaps they were never meant for our ears at all? The majority of astrophysicists believe FRBs originate from black holes or neutron stars, some of the densest and most massive objects in the universe. However, some theorists propose a more thrilling explanation. These bursts could be powerful, misaimed alien signals intended to power light-driven cosmic ships across vast distances. Regardless of their origin, one thing is clear: FRBs come from unimaginably distant sources, billions of light years away, far beyond the reach of our current technology. Closer to home, within our own solar system, NASA has detected eerie sounds that continue to intrigue and mystify. Take, for example, the haunting sounds recorded on Jupiter's moon Ganymede. These sounds are the result of chorus waves, coherent electromagnetic waves that often create auroras or polar lights. While Earth is famous for its auroras, this breathtaking phenomenon also occurs on Saturn, Jupiter, and Ganymede. The sounds you hear are essentially the converted audio of polar lights on Ganymede, a reminder of the dynamic and interconnected nature of our solar system. Mars, too, has its share of mysteries. NASA's Perseverance rover recently captured the first ever sound of a rover driving across the Martian surface. But what's truly intriguing is the unidentified, high-pitched scratching noise that accompanied the recording. Scientists are still trying to decipher the source of this strange sound, leaving room for endless speculation and imagination. As we continue to explore the cosmos, the next giant leap for humanity could come in the form of an interstellar probe mission, potentially launching in 2030. This mission, described as revolutionary as the first moon landing, aims to travel 10 times farther than Voyager 1, capturing images of our entire solar system from an unprecedented distance. With an expected lifespan of 50-plus years, this mission could redefine our understanding of the universe and our place within it. The Voyager probes, launched in 1977, have already achieved more than anyone could have imagined. Originally so named Mariner 11 and Mariner 12, these spacecraft were renamed Voyager to reflect their advanced capabilities. Equipped with technology that seems primitive by today's standards, computers with just 69.63 kilobytes of memory and data recorded on 8-track tape machines, the Voyagers have defied the odds, continuing to send data back to Earth from the edge of interstellar space. Each probe carries a golden phonograph record, a time capsule containing greetings in 55 languages, sounds of Earth, and 90 minutes of music intended for any extraterrestrial civilization that might one day find them. Voyager 1 and 2 have explored all the giant planets of our solar system, 48 moons, and complex ring systems, capturing iconic images like the pale blue dot and revealing active volcanoes on Jupiter's moon, Io. In 2012, Voyager 1 became the first human-made object to enter interstellar space, followed by Voyager 2 in 2018. These probes have provided invaluable data about the heliosphere, cosmic radiation, and the mysterious boundary between our solar system and the interstellar medium. Despite their age, the Voyagers continue to function, a testament to the ingenuity of their design. However, their power is dwindling, and within a few years, we will lose contact with them forever. They will drift silently through the cosmos, carrying with them the hopes and dreams of a species that dared to reach for the stars. Perhaps one day, an alien civilization will discover these probes, power them back up, and learn about the tiny, pale blue dot we call home. Until then, the Voyagers remain a symbol of humanity's boundless curiosity and unyielding spirit of exploration. Thank you for joining us on this journey through the wonders of space. Your support makes it possible to continue sharing the marvels of the universe with the world. We can keep exploring the stars and uncovering the secrets of the cosmos. Don't forget to check out our playlist for more incredible space content. Until next time, keep looking up.